Okay, why don't we go ahead and get started? So, if you're here and you know why you're here, you're probably fairly hardcore. And you've probably been working with SharePoint apps in the beta, because otherwise you wouldn't know about this session and you wouldn't know what it's all about and come here. It's kind of also a developer topic on the IT pro floor. I'm not sure how that worked out. But there's plenty of stuff for IT pros and for developers in the session. Just curious, how many people here would, if you had to say, no switch hitters, either a developer and IT pro, how many people here would put themselves as IT pro first? Okay, and how many people, well, I guess the rest of you would be developers. You don't even have to raise your hand. Okay, so what we're going to talk about in this session is, first of all, we got to do some background app authentication. How many people here were in the session I just gave about OAuth? Okay, so not even half of us here. So I thought there was going to be this issue where I had to do a lot of background there, and I can't not do the background here. So I have about kind of half the slides that I had in the last session, just kind of giving us the background on the different types of app authentication, what's internal versus external. So we have to go through that. Also, we're going to talk about server-to-server trust, which is basically the focus of this particular talk. We'll talk about what they are conceptually at a high level, what's the architecture. We have to then talk about how we configure S2S trusts. And then finally, we'll basically look at when you're in Visual Studio and you've got your on-premises farm and you're doing all your work, what are the things that you have to do to get things working, both in the development environment and in the testing environment. Okay, now, before I get started, there's now I've written several books over the last couple of years. I'm guessing at least one or two of you maybe have been through some of those. But there's a new one out which is called Inside SharePoint Apps, where Scott Hiller and I have written about 4 or 5 chapters just focused on app development. And there's so much stuff that we've done in SharePoint 2010 with solutions development that really changes almost negligibly as we move forward to SharePoint 2013. So we wanted this book to be, to be very specific to SharePoint app development and have all new stuff that you don't necessarily know because you're already an expert at SharePoint 2010 solution development. Of course, writing technical books, it's not fun. There's not a lot of money in it. Reminds me of the book I really want to write. The book I really want to write, you know what it is, right? 50 Shades of SharePoint. The story begins with a lonely site collection administrator amidst a mid-product lifecycle crisis, struggling to find happiness amidst a collection of stuffy and non-stimulating solutions that the corporate has made available to her. And finally, she finds this app, young and virulent. Wait, sorry. What's that? Well, what do you mean? Did I check it with them? No, I didn't even know there was an SPC HR committee. Okay, fine, I'll just go on. Okay, anyway, let's forget about that. Let's go on with our material here, and we're going to start by talking about what we used to do and what we still will do, creating SharePoint solutions. Well, what's the big problem or the set of problems that Microsoft saw with SharePoint solution development that really made them do such a big about-face in their development strategy? You've seen the writing on the wall, right? So basically, what Microsoft wants is for all of us to stop creating SharePoint solutions and to begin creating SharePoint apps. And all you can say is, God, I'm 3 life cycles buried into this, SharePoint solution story, and I'm not going over anytime soon. Now, we can still create SharePoint farm solutions and SharePoint sandbox solutions. They work just fine. But what we see is that the investment in making the story better, was negligible. And the entire investment, was in creating this new SharePoint app story. And most of the benefits that we get when we, are doing SharePoint solution development are just side effects from them adding it to apps. For instance, now there's CSOM APIs that, I can basically have JavaScript code get to do search and BCS and user profile stuff. Wasn't there before. Totally useful, for SharePoint solutions, but it wasn't really created for that. It was kind of created for the app story over there. So when it comes to security, that was one of, a set of the biggest. Okay, so there's this main problem with SharePoint solutions from a security perspective where they don't have an identity. And if they don't have any type of identity, there's no way we can configure permissions for them. So when code in your farm solution or sandbox solution runs, it always runs under the identity of some particular user. Now, sometimes that's just fine, but other cases, your code needs more permissions than the current user. So we've all written a farm solution. We've all called that method run with elevated permissions, and our code starts running basically as God. Starts running as SharePoint/system, which means your code can do anything you want to the site collection that you're supposed to be working with, or any other site collection in the farm, or anything in central admin. So obviously that's way too powerful. Okay, the other issue is sandbox solution code. Sandbox solution code cannot elevate, can't use impersonation. It always has to run as the current user. So while it kind of solves the you can't run as God problem, it causes a couple other problems. So everyone that I talk to is under the understanding that SharePoint solutions protect your stuff. Well, they protect the farm, they protect the other site collections, but they certainly don't protect the site collection in which they're activated. Point being is, if you activate my sandbox solution, you have to be a site collection or a site administrator. And then if I have activation code that basically runs when activation happens, my code runs as you. What can you do? You can do anything. You're a site administrator. So I can basically perform an attack and delete every piece of content you have on a per site collection basis. So obviously we'd like to have security enforcement, not just trust. Trust is something that we give away if we have to, but we would much rather have enforcement than have to give away trust. The other problem with sandbox solutions, is when you have some lowly user, a contributor or a visitor that hits a particular page, your web part starts running. Well, you can only do what that user can do. And if the user can't do very much, your code can't do very much. So what we're going to see with app authentication, we have some solutions to fix this problem where SharePoint solutions really don't provide any type of alternative. And the key problem is that SharePoint solution code can't be authenticated. It can't be identified as a unique security principal. Therefore, we can't configure permissions that look at who the SharePoint solution is and allow or deny it access to resources based on who it is. So you obviously know about authentication and authorization. You learn that your first year in the industry. Authentication asks the question, who are you? Authorization asks the question, what can you do? But now when we go through the authentication process, whether it's Windows authentication or FBA, or we authenticate against Windows Live ID, there's some part of the system that takes a credential, a password, or a smart card, and it compares it to secrets that it has. And if it thinks that, yeah, this is really Ted, it creates some type of receipt from authentication, a security token. And in the world of Windows, it might be a Windows security token, an in-process data structure, that's very specific to Windows and specific to a particular process. If we authenticate with ASP.NET FBA, there's a different type of security token that gets created. And if I basically use Windows Live ID, yet there's still another form of authentication that produces some type of security token. And inside the security token is some type of a mechanism for a system to validate. Okay, I see an identity inside the security token, so I'm going to believe that the party that's making the call really is that identity. And then we can have an authorization system. Given the fact that we know the identity, we can configure permissions, for that security principal. And basically, we can have an enforcement system that maps a call to an identity, looks to see if that identity has permissions, and either grant access or deny access based on that. Okay, now, SharePoint has never really done the low-level authentication. It's always pushed that out to Windows or to ASP.NET and an FBA authentication provider or to Windows Live ID. But it's always done the authorization part. Now, in SharePoint 2010, we only support user authentication and user authorization. And so users get authorized by SharePoint adding access control lists to secureable objects, things like sites and lists and items. Okay. And then beyond the level of the site collection, we also have user policy, where you can basically have a user that has no permissions in site collection 1, 2, and 3, but you can give that user a policy for that web application to have full read, or full write on every site collection inside there. So the web app, user policy kind of combines with the site collection authorization policies to basically determine what the user can do. When we move to SharePoint 2013, what we're going to see is it's not just users, but apps get authenticated. And once an app gets authenticated, it has an identity, and there's also a way that we can configure permissions for that app. Okay, now, a couple basics about authentication for users in SharePoint. We have two different types of web applications, as of SharePoint 2010. SharePoint 2010 is when we got the claims-based security support added to SharePoint. And in SharePoint 2010, I can create web applications like I should, in claims mode, or I can create them kind of in the legacy mode, which is classic mode. So classic mode is basically what we had in 2007. And then when we moved to 2010, Microsoft said, move to claims, but if you don't want to, you're scared, or you just have a lot of legacy stuff that will break, you can keep, using the non-claims model classic mode. When we get to SharePoint 2013, Microsoft is giving us a much bigger push to move away from classic and into claims-based web apps. So one thing that you'll see is that there's no longer support in Central Admin to create a web application in classic mode. It doesn't ask you, it always creates it in claims mode. So if you want to create a classic web app, you have to do it through PowerShell now. The other motivation is that SharePoint apps only work in claims-based web apps. They will not work in classic mode. So once again, just make sure that you have a classic mode web app. I'm sorry, a claims mode web app. Okay, now, as I mentioned, SharePoint 2013 supports authenticating apps. And so apps, just like users, get promoted to first-class security principles. They have to go through some type of authentication process. Afterwards, there's some type of a token in the call context that SharePoint can use to basically look at that security principle and determine whether it has permissions to do what it's trying to do. Okay, now, a very important point, and this is both in S2S that we're talking about here, and also in Office 365 OAuth, and also internal authentication. App authentication is only supported when the app calls in through a CSOM or a REST API endpoint. So it's really in the endpoints that they have this pipeline that we're going to look at. So basically, if your app tries to just do a get from default.aspx, that doesn't go through a REST endpoint, can't authenticate the app. Likewise, if you add your own custom web services to a SharePoint farm so that you can call in and basically get to yours, there's no way for you to basically get app authentication working in your custom endpoints in this version of SharePoint. If there's enough pushback from developers, maybe they'll think about adding that support next time around, but definitely not this time. You have to go through the out-of-the-box CSOM and REST API endpoints. The good news is we have some in SharePoint Foundation that are carried over, and we have a whole bunch of extra new ones that were added for SharePoint Server, so we can get to things like search, BCS, user profiles, through either REST or CSOM entry points. Now, there are 3 different styles of app authentication. So there's internal authentication, and we have to cover that one first, just so you can understand when S2S is required and when it's not necessary. In addition to internal, there's external authentication talking about OAuth, which is basically Office 365, which we're not going to talk about in this session. And then there's external authentication, mainly intended for on-premise farms, which is S2S, or what some people call high-trust authentication. Now, let's say we have this SharePoint app that I want to create. Well, first, let's differentiate between 2 different types of SharePoint apps. There's SharePoint hosted apps, and when you have a SharePoint hosted app, when it gets installed, it has to be installed in a SharePoint site, and during installation, SharePoint will create a child site under the site where the app is being installed, and that has this special name called the app web. And the SharePoint hosted app has to add all the resources that it needs, its start page, secondary pages, JavaScript files. It adds them into the app web. And so an important point is that SharePoint-hosted apps can have pages, but they don't have a server-side presence. So they can have client-side code, but they can't really have server-side code. Okay, now cloud-hosted apps, on the other hand, give us a lot more power. They definitely bring a lot more complexity to the table as you start designing and implementing them. But the big deal about a cloud-hosted app is that it's got server-side code that runs somewhere, anywhere it wants, as long as it runs outside of SharePoint. Now, the website, which runs external to SharePoint, which is the presence of your app in a server-side manner, has a name called the remote web. So the remote web is where I can run all the C# code or VB.NET code that I want. And typically, we're going to implement the remote web using an ASP.NET application, and Visual Studio has great support. However, there's nothing about the app architecture that ties your remote web to Windows or ASP.NET or .NET. So you could basically stand up your remote web on a Unix-based system, any non-Microsoft platform, anything that can stand up a website. What you'll find is, in a practical way, ASP.NET and Visual Studio bring so much to the table when you use ASP.NET and C# or VB.NET. So, if you have an infinite amount of time and knowledge, yeah, you can build it, using, Java Beans or one of those other technologies. But the vast majority of us are going to, create the remote web using ASP.NET, and then we'll pick C# or VB.NET. Okay, now let's start with internal authentication. So internal authentication is going to be the easier way for SharePoint to authenticate an app. It's not going to require registering information about the app. It's not going to require explicit programming with access tokens that we're going to see later in the session. So what are the scenarios where internal authentication is used? Anytime you have client-side calls that get emitted from the app web, they basically are authenticated using internal authentication. Okay, now, there's also less common cases where you have a page that's served up not by the app web, by the remote web. And it can use this special library that Microsoft provides called the cross-domain library. And so even though it's being served up from the remote web at domain 1, it can use the cross-domain library to basically call into the app web and get a response back. And they're using things like iframes and JavaScript code that they supply that you don't have to mess around with, that uses things like the post message API. So they can kind of get around the cross-scripting domain issues of the browser. Okay, and then the last thing that we use internal authentication, if you don't want to set up external authentication, but you have server-side code, you can have your server-side code basically configure itself to support internal authentication, and then as long as your server-side code exclusively calls into the app web, you can basically leverage internal authentication there as well. Okay, so how does it work? The first thing to see is that internal authentication involves authenticating the user with standard user authentication, just as if a user went to the browser and hit the home page of a site. So basically, there's going to be a SAML token involved. The other thing is that the call has to go through the app web. And we'll see why that is in just a second, how SharePoint's able to do that. But SharePoint is going to be able to map any call that targets the app web to a particular installed instance of an app. And the big benefit here is your app code is not required to create security tokens or manage security tokens. It all happens transparently behind the scenes. Okay, now, let me do a quick demo. Let's go back over here. And here I am on my demo machine. Here is this little test site that I have right here. Let's go ahead and bring up Visual Studio. And with Visual Studio open, we'll go ahead and say, give me a new project. And the first one I'm going to create, not the kind you came to see, but just to kind of demonstrate, what internal authentication is going to be a SharePoint hosted app, So we'll call this one Wimpy, just to indicate that real men and real women, write cloud-hosted apps. Okay, so let's go ahead, and as I create this app, I'm going to point it to a local site. And here are my choices right here. I'm going to pick SharePoint hosted. I'll go ahead and choose Finish. Now, as I run this right here, one of the things that you're going to see is that the host site has this particular URL, wingtip server. But while the app web gets created, at basically HTTP wingtip server /wimpy, that's not the URL that SharePoint allows us to use to go and basically get at that. Now, in just a second, we'll walk through this code right here, but let's go ahead, and I'm just going to hit the F5 key. And the thing that I want you to see here, the whole purpose that I'm running this demo is to look at the URL for the host web, which is the site where you've installed it, and the URL for the app web, and see they live in different domains. Okay, so if I do that, it just takes me to the app. Let me go ahead and click on this Return to Wingtip site. So here is the host web at Wingtip server. And then when someone goes to my particular app, they can either click at this or they can go to Site Contents, and they can basically see the basically the tile for that. And they click on this right here, and they get redirected over. And if I look at this URL right here, what I would like to show is that if I go ahead and I use Notepad right here, basically there is the URL, to the app web. Here is the URL to the host web inside there, and they come from completely different domains. And the idea is that if SharePoint allowed you to get to that app web by saying wingtip server /wimpy, it would be the same domain, and they really couldn't determine the difference between JavaScript running on a page in the app web and JavaScript running on a page of the host web. And basically both pieces of code would have to run as the same user identity. So instead, what they do is they switch things over, and so any access to the app web basically has to run through this special URL that SharePoint creates on demand as the app web is created during app installation. Now, the first part of this is the tenancy. So when you set up app support in a local farm, you get a single farm-wide tenancy. You can name this whatever you want. Typically, you do that with PowerShell. The next thing that we have is we have the what's called the App Universal ID, or the App UID. And basically, that is a unique identifier that SharePoint creates on the fly every time it creates an app web. And if you take the same SharePoint hosted app and you install it in 3 different sites, each one has a different app UID. So really, it identifies the installed instance of the app, rather than the app as a product itself. And then, basically, they have the domain, which the farm is using to host apps. So once again, you can configure this. I've just configured it for wingtip.com, but I can configure it to apps.wingtip.com. And then they have the app name inside there. Okay, so with that background right here, we can basically talk about internal authentication is something that, because you have to go through a specific domain, and that domain is always going to be unique just to that one installed instance of the application, SharePoint can look at the incoming request, see the target URL, and say, hey, you map to app number 3. You map to app 27. So basically, that's how internal authentication works. Okay, now, next thing we're going to do is we're going to look at cloud-hosted apps. We have SharePoint-hosted apps, and then we have 2 ways that we can run code on the server. We have provider-hosted apps and auto-hosted apps. We don't have to worry about auto-hosted apps in this session because they're only supported in Office 365, and they never involve S2S authentication. Provider-hosted apps are what we use in on-premise, or you're not supposed to say on-premise. You're supposed to say on-premises. If you like correcting people, everyone says on-premise. What do you mean? On the suggestion that No, so on premises is what you're supposed to say. Okay. Anyway, too much detail. Let's go and take a look at a provider-hosted app. A provider-hosted app basically has some presence where it's remote web, is running somewhere on the internet, or somewhere on your private network. For the context of this talk, generally we want S2S authentication because we want everything self-contained within our own private network for our company. The problem with OAuth style authentication is that you always need a connection to ACS that runs out there in the cloud. So what's nice about S2S is that everything can be private. You can run everything on a single box. You can run basically the app server and the SharePoint farm inside of a private network. Okay, now, external authentication is used only when you have a remote web with server-side code. So how does it work? Incoming calls sent from the app to SharePoint have to carry a security token, which we know as an access token. And the access token holds the app identity. Okay, the access token always has the identity of the app, but it can optionally also carry the identity of the user. When you create an access token, which you're going to have to do with explicit code, you also have the option of creating an app-only token. And the benefit of creating an app-only token is then your call can run, and it only requires the app to have the required permissions. The standard scenario is your token has app identity and user identity. And so basically, you have to have the user have the permissions, and the app has to have permissions, or the call will fail. So the big benefit of doing the technique of getting an app-only token and configuring your permissions to support app-only is that if the current user doesn't have enough permissions, your app can call in and still succeed, because only the app needs permissions. So that's basically where we get the elevation. Okay. Now, the downside to what we're going to see here is that you need explicit programming to create access tokens and pass them as you call into CSOM and REST API endpoints. Okay, now, just to highlight things, to finish off this section, we have three scenarios. Just a regular call-in with user identity, just like we had in SharePoint 2010. We have calls from an app, typically from a page served out of the app web. And so they're going to use internal security, but they also have an access token. They have a SAML token, not an access token. It's only the server-side calls that have the access token. Okay, now, let's look at this flow chart right here. So, you're a SharePoint farm. You're just sitting around looking for something to do. All of a sudden, this call comes in through a CSOM or REST API endpoint. So the first question is, let's look in the headers. Is there a SAML token? If there is a SAML token, the next question you ask is, does this request target a URL that I can map to an app web? If it doesn't, standard user authentication, just like in SharePoint 2010. However, if it targets an app web, SharePoint knows that this call has to be from the particular app. And so it sets up the call context with app identity. And because it has a SAML token, it also sets it up with user identity. So one key point here is that client-side code can't do elevation. It can't make calls with app-only identity. And I was asking guys on the SharePoint team, were you too lazy to implement that? And they said, no, Ted, think about it. How hard would it be for someone to go to the page and add the JavaScript inside there if we gave them an API? So in general, it just is impossible to support that. But now, if you look at, should I just do a SharePoint-hosted app, or should I do a cloud-hosted app? Cloud-hosted apps can use elevation, where SharePoint-hosted apps cannot. So that's another reason why you might go for the extra complexity. Okay, now how about the incoming call doesn't have a SAML token, but it has an access token? So if it has an access token, SharePoint says, okay, well, I can basically look inside there and discover the app identity. The next question it asks is, does this access token, in addition to the app identity, also have user identity? If so, it sets up the call context with app identity and user identity. And then both the app and the user need permissions for that call to succeed. If the developer created an app-only token and passed it in, well, then SharePoint will set up the call context with app-only identity, and it only checks to see whether the app has permissions and doesn't care whether the user has permissions or not. So that's your elevation scenario. And then if there are no tokens at all, it's going to try to use anonymous access, and if that's not configured, it's going to fail. Okay, so now we've kind of gotten through the basics of how app authentication works. And it's important to understand when internal authentication is used, and then when external authentication is used, which what we'll focus on now. Okay, now what is S2S, or server-to-server trust? Unlike OAuth, we don't want to require our computers to have to connect to Windows, Azure, access control services in the cloud. I just want everything to be self-contained. Now, in the last session I gave, when I talked about OAuth, that has a three-legged authentication protocol, which is far more complex than what we have here. Just to give you kind of the cliff notes of OAuth-style authentication, user calls to SharePoint. SharePoint authenticates the user, has a SAML token. The user goes to a page that has a tile to basically go to an app that is a cloud-based app running in Office 365. So then the SharePoint farm in Office 365 calls to ACS, gets what's called a context token, and then basically passes that back to the browser. The user then clicks on that tile and posts the context token to the app. The app can look in the context token and basically can do things like figure out who the current user is, what is the site where the request came in from, and then it's able to call into ACS and get an access token. Now, when you have that OAuth style, which is very different from what we're talking about here, well, you're going to have an identity established in Office 365 and also in ACS, which is called an app principal, that has a GUID called a client ID. And you also are going to need something called a client secret, which is basically a key that's only shared between the app and Office and ACS. And the idea is that they can both encrypt things, and then the other side can understand it. And all that goes away when we go to S2S. So S2S is actually a much simpler protocol. It's a two-legged protocol. At times, I've heard various people inside of Microsoft, calling this two-legged OAuth. But hopefully, within Microsoft, they're going to just refer to OAuth authentication and S2S. In Office 365, when we use OAuth authentication, the access tokens are built in accordance with the OAuth 2.0 specification. What we're about to look at, SharePoint's going to be creating access tokens, not in accordance with the spec, but with Microsoft-specific extensions for this S2S scenario. Now, Microsoft has basically sent a proposal to the OAuth Standards Committee, to basically add what they've done with S2S as part of the spec, and the spec itself isn't even in final form, and so that's the state of things. But I think it's just easier to refer to this as S2S security tokens and not two-legged OAuth. So how does this work? Well, what we have is we have the client app that runs on a server, somewhere inside of our network, and it's going to talk to SharePoint. Now, user goes to SharePoint. User goes to the site contents page and sees the app tile, clicks on it. The user gets redirected to the client app. One big thing that differentiates S2S authentication with OAuth authentication is OAuth passes this big context token with all this information. S2S, you don't get past anything. There's no context token. There's no communicating with ACS. Instead, right there on the server that runs the remote web is all the things it needs to build the access token and pass them to SharePoint, where SharePoint can authenticate them. And so the way that this is built is with basically an X509 certificate that has a public-private key pair. And the idea is that on the server that runs the remote web, you have the private key. And what the app can do is basically create access tokens and sign them with this private key and send them over to SharePoint. Now, to make this work, you also have to register something inside of the SharePoint farm that recognizes the X509 certificate and basically grabs a hold of the public key. And so anytime the server signs something with a private key and sends it, well, SharePoint can then use the public key to basically decrypt it, and we can kind of get the authentication working inside there. Now, what we're going to see when we get to configuration is you have to create a type of security token service, which is called a security token issuer, to make all this work. And the idea is that then we have something inside of SharePoint. When a call comes in, it can look at the access token and use the public key to validate it came from a trusted party. And then we can basically get the app identity and set up the call context. Now, why is it called high trust? A lot of people confuse full trust and high trust. What's going to happen is, since there's no context token and there's no ACS, there's no way to kind of push something into the app that has the user identity. So instead, the server running the remote web will just challenge the client and do a basic Windows authentication. And so it's really the remote web or the app itself that authenticates the user and creates a SAML token. And then what's going to happen is when the app creates an access token, it will basically take the user identity and build it inside there. So high trust means that the SharePoint farm just has to blindly trust when it sees an access token and it says Bob inside there, that it's really Bob that authenticated against the remote web. And if the remote web basically tries to do something and says, okay, well, it's really Bob, but Betty has more permissions, so I want to put Betty's identity and send it to the SharePoint app, SharePoint allows it. Hey, you messed up. You trusted us. So that's the trust that we have inside there. It's very different from full trust. Full trust means the code can do anything it wants. And certainly we don't have that scenario. So high trust just means we believe the app when it tells us the security principal is so-and-so. But the code still then needs app permissions to be able to do anything. Okay, so basically that's the difference between high trust and full trust. Now, you think that Microsoft does a bunch of stuff for us. Yeah, actually they created S2S Trust for themselves, because S2S Trusts are used with all this new integration into SharePoint with things like Exchange 2013, with the Workflow Manager. So all those products are going to require calling into SharePoint, and SharePoint's going to say, who are you? Hey, I'm app number 123. Oh, I know you, and you have permissions to do that. But it just turns out that they also give us the ability for us to create custom provider-hosted apps and use the same S2S trust mechanism that they use for Exchange and Workflow Manager. Okay, now the architecture is based on, as I mentioned, the X509 certificate. So the private key is basically placed only on the server or servers that run the remote web. And the app uses it to sign various aspects of the access token. The public key then has to be registered with the SharePoint farm, and the act of registering the public key creates what's called a trusted security token issuer. Okay, now the app creates access tokens, calls into SharePoint, and then SharePoint can basically look at the access token, validate that it was signed by someone who has the private key, and then it's basically going to believe the identity of the app and the identity of the user if that's inside there. And that allows the SharePoint app to establish app identity, and it allows the people that own the content of the SharePoint site to configure their permissions that they want to give away to that particular app. Okay, let's move into a little PowerShell. So, we're going to require explicit steps to configure the S2S Trust. So you have to create an X509 certificate, and I'm going to show you how to create one for testing, to create one for production. There's plenty of companies that you can go to create the X509 certificate. Okay, then what we have to do is we have to make the certificate's public key accessible to SharePoint. We're then going to use PowerShell to create a trusted security token issuer, which is always based on one particular certificate, and it's created by looking at the public key of the certificate. Okay, then we're going to develop our provider-hosted app, and we're going to give it access to the private key file. And then we're going to use this special class that gets added by Visual Studio, which is called the token helper, and that's going to help me create S2S access tokens. And then I can basically pass those access tokens when I call, either into CSOM or REST. Okay, now there's two ways that we can make the certificate available to SharePoint. I'm going to use the simple way in my demo, where basically I am going to pass it just the file path to the certificate file, the .ser file. Another thing that you can do is you can create your S2S high trust app so it has a web service endpoint available through anonymous access. So someone can call in and say, give me your metadata. And what the app will then do is basically get the key information and return it back, as a standard web service response. So that's what Exchange and Workflow Manager do. If you were creating some type of professional product you wanted to install in someone else's company, you would go through the steps to do that. If you're the only developer in town and no one's looking at how you're doing things, you can do the technique that I'm using here and get it working fine in production. Okay. Now, here is some PowerShell that we can use to create test certificates. So when you install SharePoint, inside of C program files, Microsoft Office Servers 15 tools, they add two handy utilities called makecert.exe and certmgr, certificate manager.exe. Now, one thing that you're going to need inside there is you have to specify the domain. So that will be where the app remote web lives, appserver.wingtip.com in our case. I also have to create certificate files. There's going to be one which is a .cer file, which has the public key, which I'll basically pass to SharePoint, and a second one that has a pfx extension. And the idea of that one is that it is a file that has the private key inside there, but we don't want anyone just to find the file and get the private key, so it's always password protected. So when we look at this first call right here, there's a call that we have to make cert. And this call to make cert goes out far, far to the side. In fact, let me go over here. Switch over to my machine. Over on my machine, here's the directory of the zip file that I have on the Critical Path training site. So anyone can get all the code I'm showing in this and my two previous sessions, as well as the slides. But if I go into high trust, and we take a look at this right here, here is something that we can run. And so when we call make cert, one guy at MIT wrote this thing 7 years ago, and everyone else just copies and pastes it. Okay, so basically there's all this stuff here to kind of create the certificate in the correct way. And that's what we do with make cert. Well, if you want to actually use the certificate to do SSL, well, then we have to register it with IIS. So calling that and say, take the public certificate, which is the CER file. So after you've run this script, you're going to have these different certs right here. So basically, that's the one with the public key file. That's the one we have to give to the SharePoint farm so it can discover the public key and register a security token issuer for that public key. The PFX file is the one that has the password-protected private key file inside there. Okay, and then the last thing that I show you here is you can write this code right here that looks at the cert and creates, basically looks through all the certs that are installed in IIS. And certs have this little identifier, which is a thumbprint. You know what a thumbprint is, right? It's a hash. You know what hash is, right? It's when you have a bunch of bulky substance, like a public key token, and then you distill it down to a little kind of tarry substance, which is basically the thumbprint, and then you can use that for identification. Okay, so basically after we run this right here, this basically finds the certificate and runs an export function, to create this PFX file right here. Okay, so once we've done that, the next thing we need to do is then run a PowerShell commandlet to create this trusted security token issuer. So this has a one-to-one mapping, to that certificate file. And you basically just install it on the SharePoint front-end web server, but you don't have to do it on each web server. You just have to do it on one, and basically just gets registered on a farm-wide basis. So you have a GUID, which is the issuer ID. Okay, and I have a special version of GUIDGen that I use to create these vanity GUIDs. There's my target URL. Now, you also see this get site and then get authentication realm. So there's something about apps that requires apps to run inside a specific tenancy. And so tenancies are real big in Office 365. If I get an Office 365 presence, they give me a tenancy, which is those site collections. If you do the same, they'll give you a tenancy. But they had to add tenancy support to on-premises farms to make apps work. So what we have to do is we have to create an instance of this one service application, which is the SharePoint Site Subscription Settings service, and that's what manages tenancies. And all you got to do is create the service, and it creates a farm-wide tenancy for you, which you can ignore completely until a couple cases where you have to do work with apps. So I call get SP site, and I can really pass any site across the farm. What's important, though, is I call get SP authentication realm. And so basically, I then pass the target site, and it gives me back this ID for my tenancy. And then what I have to do is I have to create this funky big string, which takes the issuer ID and appends it with the @ sign and then the ID of the realm inside there. And that's what we call the registered issuer name. Now, I also have to point this PowerShell commandlet to the physical path of the certificate CER file that has the public key. Note that down here, I have the certificate that I'm passing. Note that there is a different parameter that's supported in this commandlet if I'm passing it to an endpoint. So instead of looking at a physical key file, I want to pass it to a URL that the S2S app has exposed with anonymous access. So either technique will work inside there. Okay, now when I go ahead and I run this right here, what you're going to see is I've already run this on my machine, but it's going to come back and basically say I've created this token issuer for you. Here's what the registered issuer name would look like. I encourage you every time you do this, to have some code like I have right here that basically takes the token issuer and basically just writes it out to a file. So then you have something where things like the registered issuer name and the issuer ID, and if you ever need the thumbprint inside there. Okay, so that's step one. So now I got this security token service inside there. If I go back on my machine right here, and we do a add, and we'll have a PS snap in, and we'll say Microsoft.SharePoint.PowerShell. And so if I call get SP trusted, now there's SP trusted identity token issuer. That's not used for app authentication. That was there, added in SharePoint 2010. That's the one that does the user authentication and basically creates the SAML tokens. So we're not creating SAML tokens, so we use this one down here, which is the trusted security token issuer. And if I have one on my farm and I go ahead and run this right here, I'm going to see this. Now, once we've done that and we've got this thing registered, well, the next thing we have to do is we have to register the app principal. Now, if you went through some of the MSDN papers and looked at the support in the beta, it was unnecessarily confusing because they always use the same ID for the token issuer and the principal, which doesn't need to be. And if you do that, well, that means every time you want to create a new app, you got to have another certificate. So in this new set of tools that the Visual Studio team just released, which is basically their Preview 2 Visual Studio tools, they now have much better support. So once you create the certificate and you register the token issuer, you can have many different S2S apps, that all leverage the same one. Okay, now, next thing we're going to do is we're going to call register SP app principal. Now, once again, if I move over to my other machine right here, and we take a look at this script right here, you're going to see that a app principal has its own GUID. So there's no need to use the same GUID, and you shouldn't use the same GUID as the token issuer, so you can distinguish the two of them. You give it a display name and a client ID. Okay, now, we have to create the full app principal identifier, which takes the client ID and adds the realm inside there. And then we're going to go ahead and register this guy right here. And you can see when you register it, there's the name identifier, there's the site, there's the display name. And after you've run something like this, we should be able to come back and take a look at what we created. So here's what the name identifier looks like. Now, one thing that really confused me at first was I registered this thing, but I didn't register the token issuer ID. How the heck does it know? If I have two security token issuer IDs, and I have my app, and I create my app, and I register the app principal, and I haven't pointed to one or two, how does it figure it out? And what it does is it uses the thumbprint. So as the access token comes in, not only does it have things that are signed by the private key that they can discover with a public key, there's also the thumbprint. And so what SharePoint can do is basically just look at all the different token issuers that are registered and look at all the thumbprints and find the thumbprint of the incoming call and match it up to that thumbprint. So just don't be confused when you kind of don't see how you're assigning anything that establishes the connection between the app principal and the token issuer ID inside there. Okay. Now, it turns out that Microsoft kind of gave us this register app principal. I could also use this reg app new page to register one of these. So for instance, if I go back to my site, they don't give you a link to this. But if I come back here and I say appreg.new.aspx, they give me this page right here. So given the fact that we've already got the security token issuer registered on the machine, you could do the app principal registration from here. And as we do this inside here, I can create my own client ID. Also note that SharePoint is very dyslexic, going back and forth between app ID and client ID when they're the exact same thing. So don't kind of think that they're different, and unfortunately they're just not consistent. The app ID and the client ID are the same. So here, you can either put in your own GUID, or you can generate a GUID. There's the app secret, but the app secret isn't used. That's only for OAuth in Office 365 where you need the app secret. So you can kind of leave this blank. And then you put in a title. You put in the domain of where your remote web is. And then optionally, you can put in a redirect URL. The redirect URL is used when we want to register permissions on the fly. Now, if I go back and I take a look at register app principal, unfortunately, they didn't put enough parameters in for all scenarios. There might be some scenarios where this is fine. But there are two things that you cannot register. You cannot register the domain for your remote web, nor can you register a redirect URL. When would that hurt you? Well, let's say that from your remote web you want to serve up pages, and then you want client-side code to basically use the cross-domain library to basically make calls back into the app web. That's not going to work unless you've registered basically the domain for your remote web, because it has to open up those calls only for certain URLs. The second thing is if you want to support registering, getting an authorization code and basically obtaining permissions on the fly, you need a redirect URL. So I wanted to show a second example where you can actually write more code here. And this one is going to be a little bit more hardcore because it's going to go right against the SP app principal manager. Wasn't it great when they just made PowerShell totally open to .NET developers? Use Reflector, hey, that's in there, I can go ahead and call it. But I can use this technique right here to basically register the domain for the URL and the redirect domain. Now realize that if I'm doing development work, I have to register it once for my local host site, and then I have to do it a second time for the actual site I'm going to use somewhere else. But by going through the App Principal Manager, I can register the domain for my app web, which is called a application endpoint authority. And also I can get the redirect URL inside there. So you can see how fun this is. You call basically, you create a new app principal credential. Once we do that, we have to create something which is an external app principal creation parameter. We go ahead and we add the redirect URL, and then finally I can create the principal. So with the PowerShell script like this, you can configure every aspect of the client ID, aka app ID, that you need to do. Okay, so once we've gotten there, we've covered a lot of the difficult stuff, and now we can kind of get into beginning to use it. Now, I basically just did the demo as I went through the slides, so I'm going to keep moving on here. But what's important to see is that at the very least, before you move to Visual Studio, you want to have created the certificate, and you want to have registered the security token issuer associated with that certificate. It turns out that when you're developing, Visual Studio can just create the security app principal on the fly for you in your debugging environment, so you only need to explicitly create it when you move to production for testing. Okay, so we'll now move into the last section, developing S2S apps. Okay, so what are you responsible for as the developer? So you have to expose an endpoint to SharePoint to discover the service metadata, or take the kind of low-tech approach of just putting the .ser file of certificate on the web server when you call the new SP Trusted Security Token Issuer. Secondly, your app has to authenticate the user, which means that your remote web has to force Windows authentication. Okay, and then you have to create security tokens. So as I mentioned, S2S tokens, kind of like OAuth tokens, but they're built a totally different way, with what we call a two-legged authentication protocol as opposed to a three-legged one. Security token is going to be required to have the app identity, and you can optionally include the user identity. And then the security token has to be signed with the private key, which means that the remote web needs access to the PFX file at runtime. Okay. Now, once I've got all that set up, what we're going to see is that there are two methods inside the token helper class that are specific to S2S. There's get S2S client access with Windows identity and get S2S access token with Windows identity. Now, there's a couple things where maybe it could have been a little bit better. So one of the things that we have here is that in the token helpers class, there is support for taking an established Windows identity and putting that into the access token. What if you're using FBA? Can you make it work? Absolutely. Does Microsoft give you any code? No. You've got to go look at those methods and kind of figure out how to do the same thing with the FBA identity that they're doing with the Windows identity. And can you do it with Windows Live ID identities? Yeah, but same thing. The only thing that they've given us the starter code for is when we authenticate using Windows identity, which will definitely be the most common one, inside of your on-premises farms, but not the only one. So that's kind of a pain point that we have. Okay. So with all that, let's go back over here to my development machine. And I come down here and let me stop the last thing I was running. And now we'll come down here and we'll say open project. and I'll go into high trust. And if I look at my high trust app right here, let's start by looking at the app, and then we'll look at the remote web. So when I look at this app, and then we look at the app manifest, what we're going to see is that we have to put the start page that points out there. I can just use remote app URL in development, and Visual Studio will figure that out by looking at the associated remote web. Note that this value right here, how does Visual Studio figure that out? Well, your app project, if I look at its properties, has this thing called the web project, which basically you can assign a value to another project, which is your remote web. And so the idea is that when you use this right here in your app, Visual Studio says, okay, what's the web project? It goes to the web project and basically just sees what it's using inside there. Also, realize that you have to have Windows authentication enabled, which in the beta versions of the Visual Studio tools, you had to do that explicitly, but now with the new preview tools, they automatically, configure that the right way for you. So you have remote web application, which basically means provider-hosted app, and you have to put the client ID inside there. Now, when you come down and look at the web.config file, what you'll see inside the web.config file is you need the client ID, because they're going to need that when they build the access token. Secondly, you have to have a client signing certificate path app setting that points to that particular file. So this file has to be somewhere on your machine. Now recognize that if you got this file, you couldn't find out what the private key is unless you had the password. But here you can see that the client signing certificate password has to be passed inside there so they can open up the PSX file, use the password to basically get the private key so they can sign the access token. And then you also need to pass the issuer ID. The issuer ID has to be put inside the access token for basically the validation process to work. So before this last thing that the Visual Studio team just released, the Preview Tools team, in the beta, they kind of munged things together, where the client ID and the issuer ID were both the same, which worked. But then it kind of pegged you to only having one app per certificate, which is not necessary. Okay, once you get all this stuff worked out, well, now I can basically go and start, writing code inside here. And here's some, basic code. So let's go ahead and instead of starting that up, let me go ahead and close all documents. And I might have the issue where this thing's installed but did not uninstall my high trust app. So there's a problem, no site URL. Okay, so now if we go back here and we add this inside here, and invalid does not exist, and maybe that's because I didn't run this guy ahead of time. So if I go back here to high trust and we open up something to register my app principal with, that's not the one right there. I think if I go find, not that one, it's going to be one of these guys right here. And sorry for floundering around. Where's the one with the 333? Okay, this is the guy right here. And just make sure that this domain right here maps up with what's being used inside here. So let's go back here. Hey, this is using 44302. That's great. Okay, so now let's go ahead. Let's run this. (44302). Good thing you guys told me that. Okay, let's see if I can go back after the fact and fix this, or if I'm going to have to unregister. Why don't you tell me before I did the stupid thing instead of after? Okay, let's go ahead, see if this runs. Now I've got that thing registered inside there. And so now let's go back here and run this right here. Okay, so do you trust this? It's doing all kinds of things inside there because this app is requesting permissions to do various things. We go ahead, I say trust this particular app. Now notice that sometimes it brings two websites up. The HTTP one, which hasn't been set up for debugging, and that just kind of fails because the code's trying to get an access token, but then it brings you to this guy right here. Now, if we come up here, and we use Fiddler, and then I come back here and say remove all, and then let's go ahead and refresh that guy one more time. What we'll see here is the very first thing that happens is it basically calls this get client context with Windows identity. Doesn't have to make any calls because it's got everything it needs right there in the server to basically build the access token. And then whether I'm using CSOM or REST, there's a different method to call inside here, but now I call CSOM as usual. And when I come back here and I take a look at as it made this CSOM call inside there, you can see the S2S access token is being passed in, which is going to allow SharePoint to look at the access token, match the thumbprint to basically find the right certificate. It then has the private key that signed things, so it takes the public key and uses that to authenticate that the token, is valid. And if it's valid, okay, let's look at the issuer ID. Yeah, that makes sense. Okay, let's look at the client ID. It knows the app principal. It then can authenticate the app and check to make sure the app has the right things inside there. Okay, I'm about 4 minutes over. I'm going to give myself 3 more minutes because of that obnoxious lady that kept talking and blowing her horn, thinking it was New Year's or something. And you're going to like this last part because this is something that they've done in the Visual Studio tools to make your life much easier. So how many people worked with S2S during the beta? Anybody? Okay, a couple. And you had to kind of do all the stuff I was doing there to get things working. So let's say that I want to do an S2S app. I'd say, well, first of all, let's stop debugging. Then let's go ahead and say new project. And let's create one which is called Quitting Time. And as I create this guy right here, I'll create my app. And I'm going to go ahead and make sure it's provider hosted. Because of the 3, that's the only type that supports the S2S scenario. And in previous Visual Studio tooling, you were done at this point. Now, it basically says, what do you want to do? Do you want to create a provider-hosted app for Office 365 and OAuth? No. I want to use a certificate. So now Visual Studio says, point me to the PFX file and give me the issuer ID and give me the password inside there. And so it's going to basically put the right things that need to be in various places. So I go ahead and I run this inside here. And if I take a look at the web.config file, you can see what they've done. And there's no client ID yet. Why is that? Because it's going to be created at runtime. Every time you hit debug, what Visual Studio is going to do, because it's your friend, is it's going to register a client ID. It's going to create it on the fly, and then it prevents you from having to call, SP register app principal or use any of those other techniques. So basically, it's just for debugging. It then is going to update this file. Now, one thing that they need to do to clean up a little bit is they should get rid of this, because the client secret is never used in the S2S scenario. That's only used in OAuth. And probably by the time it's released, that will not be in the S2S scenario. But then they put in the certificate password and all this other stuff inside there. Okay, so now that you've seen that, let's go ahead and I'm going to hit the F5 key. And will it work? So I go ahead, hit the F5 key. Quitting time, do you trust it? I go ahead and run that. Seemed to work just fine. Okay. Is anyone here from the SharePoint product team? Anyone? Okay, good. No one's here. Okay, I can show you something I would never show if they were in the room. Okay, so you know how we can basically do things where we look behind the scenes inside those databases that the product team says, if I see you showing that to someone, I will kill you. So let's go here, and behind the whole infrastructure for apps, they have this service application, which is the app management service, which has its own database behind it. And if I look at the different tables inside, there is a table for app principals. Don't tell anyone I showed you this. Oh, darn, is this being recorded? Oh, man. Okay, so I go ahead and say select rows inside here. And what you can see is, every time we register, one of those particular apps, they've put something, inside here to basically identify that. Hey, and there's quitting time. And I look over there, and they've registered the realm and everything for that. So what's going to happen is every time you start a debugging session, they're going to basically add that inside there. And when you stop it, it pulls it out. So once again, it just kind of gives me the ability to kind of create it, hit the F5 key, have things work. And as long as I've registered, the security token issuer and the certificate, I don't have to worry about the other junk, as I just want to do development and test things, and I can kind of worry about the client ID registration, in a more structured manner when it's time to actually test and send things into production. And so, as I promised, that is all the content that I want to show. I was told to tell you to fill out your evaluations, but I'm sure I'll forget. One last thing I want to do. I think I mentioned the code that we have. If you go to Critical Path Training, I think I don't have an internet connection here, so I'm not sure if I'm going to be able to get there. In our members section, I have basically a single zip file that has all the PowerPoint slide decks and all the sample code for all 3 sessions I did today. One other thing you might not know about Critical Path Training is recently we've started partnering together with a company called Pluralsight. And Pluralsight is a company that doesn't do what we do, which is instructor-led training. They do on-demand training. And they have an incredible breadth of, you want to learn F#, you want to learn APIs for Facebook. And so basically we've given them a ton of SharePoint content that has a much lower price point. And to kind of get things excited, what we've decided to do is to basically just open up our SharePoint 2013 course from today till the end of the week, just to kind of get some exposure. So if you go look at the Pluralsight site and you want to basically see some of our on-demand lectures for a SharePoint 2013 training, that's available to you. So with that, I will wish you adieu. I now have time if people have questions. I'll just take the questions off.